Hello AWS users, presenting to you the general availability demo of Aurora MySQL Zero-ETL integration with Amazon Redshift. This video is the successor of public preview demo from June 2023 as the feature is now generally available. Please note that at the general availability of this feature, your source Aurora MySQL cluster has to be version 305 or above, which is compatible with MySQL 8.32 or higher. Let's look at the demo. For this Zero-ETL integration demo, we assume a fictional website called Ticket, where users buy and sell tickets online for events, concerts, shows, etc. The transactional data for Ticket gets written in Aurora MySQL, and analysts would like to do real-time analytics at enterprise data warehouse scale. They would use Zero-ETL integration between Aurora MySQL and Amazon Redshift data warehouse. Let's get started. Open AWS Management Console. Access the source interface. In this case, the source is Aurora MySQL, so we will access Amazon RDS console page to get started. If you were to create an integration from DynamoDB to OpenSearch, you would start from DynamoDB console. And then you have to go to Zero-ETL integration in the navigation menu. Click on Create Zero-ETL integration button. A wizard will open. In step 1, provide your integration a name. Click on Next and move to step 2. In step 2, you will browse your source, an Aurora MySQL cluster in this case, that we have already created. Remember, the cluster has to be version 3.050 or above. After you choose source database, you may get an error fix parameter values in case if you're missing prerequisites for the source. Click on the checkbox under the error which says fix it for me and click next. The wizard will show you the missing prerequisites and the steps it will take to automatically fix it for you. For source Aurora MySQL, you need to turn on enhanced binlog and turn off binlog. It requires you to modify 6 DB cluster parameter group values. The wizard automatically creates a random clone of existing DB cluster parameter group, modifies the required 6 parameters automatically and attaches the new DB cluster parameter group to your Aurora MySQL cluster. This change requires a reboot of your Aurora MySQL cluster, so you would have to confirm and provide a consent before proceeding. When confirmed, click on Reboot and Continue button to reach step number 3. This is where you pick your target, which is a Redshift serverless data warehouse in this case. Browse Redshift data warehouse, select using the radio button, click on Choose. Once again, if you're missing target configuration prerequisites, it may give you an error like fixed resource policy and or case sensitivity parameter. Click on the checkbox under the error which says fix it for me and click next. The wizard will show you the changes that it will automatically do on your behalf. The two required changes on target are: number 1, resource policy, which allows the source Aurora MySQL cluster to be an allowed integration source for the target Redshift data warehouse. The second is setting case sensitivity parameter for Redshift. At the cluster level, Aurora MySQL is case sensitive by default, while Redshift is case insensitive. This change will make Redshift case sensitive by default. Review both changes being made by the wizard and then click on Continue. You will reach step number 4, where you can choose your own keys for encryption. All Zero-ETL integrations are encrypted and use the default KMS keys. If no intended changes have to be made to encryption, click on Next to reach the step number 5, where you will review all your changes and will finally create your Zero-ETL integration. Now wait a second. We asked the wizard to fix a couple of steps for us. Let's review the source and target changes being made by the wizard. You can see the steps being applied in the progress bar at the top of AWS console. You will find a View Details button to check the status of changes being applied by the wizard. The target changes were quick, successfully completed in no time. Let's view details of source changes too. A copy of DB cluster parameter group was created. The 6 parameters were changed in that new DB cluster parameter group. Associated the source cluster with this new DB cluster parameter group, and finally the reboot is happening right now, which should take about 2 to 3 minutes. I'll fast forward to the reboot completion, which took about 2 minutes for me. After completion, verify all the steps were completed by clicking on View Details button for source. If all looks good, scroll down to the bottom of step number 5 and click on Create Zero-ETL Integration button. Your integration will now be creating. It takes about 15 to 30 minutes for an integration to transition from creating state to active state. Let's pause the video and come back in 15 minutes. All right, the integration is active. Let's use this integration to create a database in Redshift. Go to Amazon Redshift console and open Query Editor V2 from navigation menu or using the Query Data button. In the Query Editor V2 client, initiate a new connection using your credentials and execute a select on svv underscore integration table. You will use the integration ID returned to run a create database from integration command. So let's pick this integration ID, put it in the create database from integration statement, remove the white spaces if any from this integration ID copied from previous result, execute the create database, and now you should have an active sync setup completed from Aurora MySQL to Redshift. It's time to look at the Zero-ETL integration sync in action. So for that, navigate back to the Amazon RDS console. In databases, select the Aurora MySQL writer instance and copy the writer endpoint. This will be the host name for our Aurora MySQL connection. Connect to Aurora MySQL cluster using your client application. In this case, we'll use EC2 instance as Aurora MySQL client. Select the EC2 instance, click on Connect button. Choose Session Manager and then click on Connect. This should open a session where I already have a MySQL CLI installed. Now run MySQL CLI command to connect to the Aurora MySQL writer endpoint that you copied earlier using your login credentials. Alright, we are connected to Aurora MySQL cluster. Now we will grab a few DDL and S3 load DML statements to create the ticket dataset and load it in Aurora MySQL. With our integration being active, all these DDL and DML changes that we are doing here should be synced into Redshift Data Warehouse in seconds. While we let the load from S3 statements go, let's go and check if the tables created are being reflected in Redshift or not. So refresh your Redshift Data Warehouse in Query Editor V2 Tree View panel. This should have the tables that we created in Aurora MySQL already synced. So as you can see, the tables are created. Now let's check the loads getting synced. Open another editor tab, choose your cluster and database that you created from integration, and check the statistics of load currently in progress in Aurora MySQL. We are running a SQL to get counts in Redshift. Check it against the source. We see that the 5th load out of 7 is in progress. And if you look at Redshift, the first 4 loaded tables have already been synced. We'll let the source loads continue. In the meantime, I'll share another important concept. That is monitoring your integration. In Amazon Redshift console, click on the Zero-ETL integration on the navigation menu. What you see here are CloudWatch metrics to monitor your integration on the target console. You can see metrics like lag of your integration sync, tables, success failure statistics, and then detailed table statistics in another tab. I would also like to mention that had you not created database from integration in Query Editor V2, you could have created database from integration in this GUI interface as well. Good times, we can see with time lag is either keeping consistent or getting better around 10 to 11 seconds. Let's navigate to Query Editor V2 and confirm all our tables are synced. Alright, yes they are. So that's all we had for now. Hope you liked the demo and will use this feature for your workloads very soon. Thank you so much for watching.